Hi, kids! We are going to learn about why diamonds are so sparkly. Um, you are going to have to do this one first, so make sure you do this. Okay. I will then, we're going to work through one. You're going to have to work through one more on your own, and then we'll take from there. You will need your protractor. Okay. Here is a diamond. Diamonds are cut like this shape for a reason. In fact, diamonds that have the correct cut, there's all these angles have to be just perfect, and how deep this is, and they're cut like that for a reason. So typically when you look at a diamond, you look at it, you're looking down from the tops. You're never looking at it from the bottom. So we're going to draw a light ray coming down from the top. Okay. I'm going to draw a light ray coming down over here, someplace straight, more or less straight down. It doesn't have to be perfectly straight down, but use a protractor to make sure it's coming, or a straight edge so it's coming in straight. Okay. So there it is. Okay, so there is going to be my light ray. Your light ray might be a little bit different than mine. That's okay. Okay. But I want to go through all of the steps on drawing what is going to happen to this light ray as it enters the diamond and then bounces off and stuff like that. So first thing we have to do is where it hits, we have to draw a normal line. Okay, so we're going to use our protractor and draw a normal line in. Does everybody see how I'm actually using my protractor to line up along the 90 degrees? And I'm going to draw a dotted line to represent my normal line. Okay, then I am going to measure my angle of incidence. So my angle of incidence is always measured from the normal line. For me, I get 30, looks like 3 degrees. Okay. Now, you might not get exactly 33 degrees because you might draw it a little different, and that's totally okie dokie. Okay? But then we have to do Snell's law. So first, do we have to worry about the critical angle when the light is going from air to diamond? The answer is no. Because the critical angle is when the refracted angle is 90, and if it's slowing down, it's never going to get to 90. Okay? So in this case, we don't. So I'm going to just write it out. Snell's law is this: n1 sine theta 1 equals n2 sine theta 2. So I would say 1 sine of 33 equals 2.42 sine of theta 2. And then let's solve for theta 2. And you should do the same for your angle. Okay, remember, if you don't have 33 degrees, that's okay. Okay, sine of 33 divided by 2.42. Inverse sine of the answer, and I get 13 degrees. So that means my refracted angle has to be 13 degrees. Now, I want to show you here something, or show you something. A common mistake I get is I get students that they'll draw it on this side like this, okay, at 13 degrees. Guys, that doesn't make sense because then the light ray is bouncing off the normal line. Is the normal line a real thing? No. Okay, so it has to be on this side at 13 degrees. So make sure you draw it correctly. So from the normal line, I'm going to go 13 degrees, and then I'm going to draw it in. Okay, and I'll label it 13 degrees. All right, so now, okay, it's going to hit the surface here. So again, when it's hitting the surface, what do you have to do? You have to draw a normal line. So let's draw our normal line in. Okay, and I have a new angle of incidence. So I have to measure what that new angle of incidence is from the normal line. And I get 68 degrees. So from here to here is 68 degrees. Okay. You up here should have figured out what the critical angle is. Okay. That's going to be bigger than the critical angle. But I want to show you something. If you were to try to punch it in your calculator, so let's say I was doing this, and I did 2.42 sine 68 equals this, divided by 1, because the n of air is that, and then I try to go inverse sine of that, I get, oh, domain error. You want to know why? Because Snell's law only works if the light is refracting. If this is bigger than the critical angle, and it is, okay, then the light is not refracting. The light is going to reflect. So then it has to follow the law of reflection. So then on this side, I have to draw it in at 68 degrees. All right, 68 degrees. Now again, ladies and gentlemen, you might be getting slightly different angles than me. That is totally okay. 68 degrees, and the light is going over here. And then guess what I have to do? Oh yeah, I have to draw a new normal line. So we're using my protractor, drawing it perpendicular to the surface. Like this. I'm going to measure my new angle of incidence, and I get 28 degrees. And again, you should have done this up here, and you should already know, yeah, that's bigger than the critical angle, which means the light's not going to refract, the light's going to reflect. Now, again, if you tried to plug it in, it's going to give you a domain error, because it's going to tell you, hey, that's telling you that it's going to reflect. So if it's going to reflect, it has to follow the law of reflection, so let's have it then bounce this way, 28 degrees. I'll move my protractor so it's easier to measure. 28 degrees. So then the light's going to come up, go this way. Where that's 28 degrees. Draw a new normal line. There we go. Measure my new angle of incidence, and I get approximately 11 degrees. And you should know that, you did this up here, and you should know that 11 is smaller than the critical angle, which means the light is going to refract. So then if I set up Snell's law, I would get 2.42 sine 11 equals 1 sine theta 2, and my new refracted angle is going to be 2.42 times sine of 11 inverse sine of my angle, and I get my refracted angle is 27.5 degrees. So then I have to draw the light. Again, remember, it's not going to bounce off the normal line. I have to draw it on this side at 27.5 degrees. So let's do that. 27.5 is right there. So then I have to draw it in. So it looks something like that. Okay. All right. I have just finished one light ray. We just finished one light ray together. You need to do a different light ray. Okay. You can do it. You can have it hit any place along the surface. Okay. Couple things I want to tell you. Typically, you don't look at a diamond like at a super big angle like this. So have your second light ray more or less come straight down someplace. If you want to draw it over here, great. If you want to draw it here, great. You probably wouldn't want it to come straight down so it's going to hit right there, because it's going to make it really hard to do your Snell's law and draw it out. But if so wherever. So let's say I would recommend maybe having it come down over here, or having it come down over here. Okay. So one of those two spots. Use a different color, and figure out where it's going to exit, and then finish that page. All right. Buckets.